Hello, all. As always, I'm Fusion Phil, and today I'm bringing you a new series I like to call Milling Mondays, where we will be going through different mill programming scenarios to help advance your skills. This week's video, I'm going to walk you through how to machine a throttle body spacer, as well as the second op for machining off the hat and adding our backside chamfers. So with that, let's go ahead and jump into it. All right, as you can see, I have my part open inside of Fusion 360 already, and I'm sitting in the design workspace as if I just imported this part. So the first thing I'm going to do is I'm going to go ahead and switch from design to manufacture. And inside my manufacture area, this is where we're going to do all of our cam for the milling of this part. So at a quick glance, as I rotate my part around, we can see that there is a chamfer on both sides. So this will be a 2-op part. As well, we're going to go in and we're going to create our setups for that all inside of one file. So some people mistake the idea of doing all of your setups in one file. It's good practice to get into this. It also allows us later to run 2 vices if we wanted, one with op1, one with op2, if we had to make, say, 500 of these. So the very first step I'm going to do is I'm going to make sure I'm in the milling tab. If you don't do this due to muscle memory like myself, a lot of times it's okay, because the main button we're looking for is the setup button. So I'm going to go ahead and click my setup button. And as you're going to see, I did luck out where my part here came in the correct orientation to the world. Now, for some of you, when you're doing these parts, this may not happen. The cool thing is we can actually just work through our menus and get that all set up. So in some cases, if you've caught my last video, you're using machine sim or machine configurations. You want to be able to select that. You could do so right here, but we're going to skip this because it's a pretty simple part, and it's more important. Let's get some toolpaths on this part than anything. So we are doing, like I said, is we could toggle between the different tabs here, but we're going to do milling. And then what I'm going to do here is I'm actually going to tell the software, and this is a personal preference that I've learned over the years, it always comes down to the end user. I like to use Z and X if I'm 3-axis or 5-axis. I like to use Z and Y if I'm doing a lot of 4-axis work on a horizontal. So again, there's no right or wrong here, but all we're doing is we're telling the software what axes do we want to define. So I'm actually going to tell it I want Z up based on this top face, or I could use the cylinder face. And then I want my X axis pointed in some direction. Well, in the case of my machine, I don't want all of my chips technically to come to the front, maybe. I'm going to use this flat over here for my X-axis orientation. So now that we have our Z and our X selected, or X and Y, Z and Y, whatever you chose, we need to set the actual point of reference. So this is going to be your WCS point. So as you can see here is I'm using a stock box location. So we're basing this off the raw material. And let's say, for example, my machine doesn't have a probe. I'm going to go with the back left corner, top of my part. Very easy to define at my machine. Seeing how this part is one body inside of here, the body is already selected for machining, and we don't have a fixture. So let's jump over to our stock. In this case, this is very common that it comes in as a relative size box. I always suggest to most people, you're either going to go fixed size box or fixed size cylinder. Now, if you have a stock body, you may go from solid, but we're going to stick with the fixed size box. Fusion 360 is automatically rounding everything up by a ½ inch to fit my part inside here. The one thing that I can see here that I don't like that I would adjust is my model position in the Z axis, because I do need somewhere to hold on to. So let's go ahead and adjust that right here. So our model position below our Z is I want to offset from the top, and I'm going to offset just enough to make a cleanup pass. So as you can see, that 30 thou has brought my part up closer to the top face. So again, just to recap real quick before we jump into the last tab, we set our axis directions, we set our WCS location, our work coordinate system, your G54, your offsets. We then fixed our stock size. Then last, we jumped in over here to post-process, where if you want to give it a specific program name, I'm going to also give this a comment. This is my throttle body spacer. And then lastly, I'm going to actually set WCS to 1. And I'm going to recommend for all of you that you right-click and save this as a user default. And the reason why is later on when you're posting out, if this is 0, it will cause conflicts and problems. In the post processor, 0 and 1 always tends to be the default first number in series. Again, this is just a tip to help you later on. So from here, I'm going to go ahead and hit OK. And as you can see, we have now created our very first setup. So now that that setup has been created, we can jump into our roughing cycles. So it's up to you in the order that you always do this, but seeing how I kind of have a larger flat part, the first thing I may always go for is a 2D face. The nice thing is with the default deployment of Fusion 360, we can actually kind of just work across our menu and use additional toolpaths as needed. So I'm going to go to this very first icon, which is the face icon. And from here, I always love to tell people, and this will keep you out of trouble, is you can hit OK, and the software is going to prompt you as to what the problem is. So let's go ahead and hit our OK button. And what you're seeing is it's prompting me to pick a tool. In this case, I did pre-program this part with a couple of tools. However, some of you are going to see a warning when you go to the Fusion 360 library, and you're not going to see any tools. So this is something where I'm going to tell you is you want to turn on all your libraries, and then you will see this large amount of tools inside of here. So from here, I'm going to tell it on the right side, we're going to filter by a face mill. I'm just going to grab a 2-inch face mill. And for the purpose of putting these paths on the part, I'm not going to concern myself with speeds and feeds, as it is more important initially for you all to understand how to program a part before we do those fine-tuning adjustments. So as you can see, it's automatically now recognized my stock, where my part is, and what it should be facing off. Now, I would like to fine-tune this a little bit, and let's walk through some of these menus. So as you can see here is we actually have our tool selection, and let me go ahead and expand this out for all of you. Our second tab is our geometry. So in the world of milling, it's very great to think geometry is kind of always your XY area of working. So as you can see, my stock selection is coming from my setup, and that's my yellow boundary. So we are working, based on that stock size. My heights tab is the Z axis, and something here to always remember is anything inside of Fusion is always a top-down approach. I like to take my heights from a bottom-up approach. So my bottom height is basically how deep are we going, right? We're going to go to our model top. Our top height is where we're going to start from, which is our stock top. And then we could roll up from there with our feed height, our retracts, and our clearances. Again, a lot of times we're going to adjust these based on clamps, maybe, cutting down machine time, things of that. But for our very first walkthrough of a facing cycle, there's not much here to adjust. Now, our passes tab, this is where I tend to always direct people this is the blue lines on this toolpath, right? So as you can see here, I have the blue lines. I have some options to extend the blue lines. I also have, which direction do the blue lines go, as well as how much of a step over do I have for my blue lines. So if I go ahead and type in 1 inch versus 1.4, and I hit OK, you're going to notice that I actually obtained more blue lines. So when you're really getting into the nitty-gritty of Fusion, I always want to reference the color of the lines or what exactly you're trying to do. So again, is where the blue lines are and what it's machining tends to be, geometry, the containing of the blue lines. Now, extending the blue lines or adding and subtracting blue lines goes back to the passes tab. And the nice thing about this is the passes tab, as you can see, shows you blue lines within that profile. The last one is going to be linking. And for most of you, there's not going to be a lot of adjusting here at first, but this is going to be all your kind of green, yellow, and red lines as needed. So again, very simple right out the start to get that facing profile on our part and to machine it or deck it, so to say, to make it nice and flat based on what's going on. So from here, we're going to go ahead and jump into some roughing. So now roughing is going to be something you need to make a decision on. So we do have 2 different strategies. And if you don't know really what's going to work best for you, I always tell people just do both toolpaths and delete whatever one you don't like. So based on 2D and 3D, there is several different roughing strategies here. Now, it's up to you which one you go with. I prefer 3D roughing strategies over 2D and only use 2D as needed, but we're going to walk through both of those. So what we're going to say is we're going to start out with a 2D adaptive clearing. I'm going to go ahead and change my tool out. So we're going to go to a 1/2 inch flat end mill. And then down here at the bottom is we can see there's a lot of different speeds and feeds if you're choosing a default 1/2 inch flat from the library. The case of this part, it's aluminum. So we're going to go ahead and say aluminum roughing. And from there, as always, I tell people, go ahead and hit OK. And what you're going to get is a warning. And this warning here is telling you that, hey, you need to actually tell us where the pocket is or the boundary you're trying to machine. So I'm going to go ahead and go back into that toolpath. And as you can see, the pocket selection is now highlighted. And I need to define an edge or a boundary. Here's a key thing, though, is I need to be aware of what edge I am selecting. Because if I'm picking the edge down at the bottom of the chamfer, I'm going to mill into my part. Again, that geometry tab is only aimed at a XY boundary limit. It's not a Z limit in any way, shape, or form. So again, we're going to go ahead and hit OK now, and we're going to notice that we actually have a profile cutting out our part. So we are coming around. You're going to notice there's a lot of arcs and a lot of loops here. This toolpath is designed for the side of the end mill or using the flutes of the end mill, not using the entire width of the end mill. So now that we've gone around and we've machined the outside of this part, I'm going to go ahead and make a couple of adjustments. So what we're going to do is we're going to go back into 2D adaptive. I'm going to go to the passes tab. And then the very first one that everybody always asks me is optimal load. Optimal load is where you're going to set your step over. I'm using a 1/2 inch end mill. Maybe I'm using like a VF2. It's got some horsepower behind it. So I'm actually going to step this up to a 0.2 step over and then hit OK. And what we're going to notice is we're getting a lot less passes around our part. One other thing that I may want to take into account is if I look here, it's a little transparent, but you can see we're only machining down to here. We're not actually machining past the bottom of my part. So I'm going to go ahead and I'm going to make an adjustment to my Z heights to be able to machine deeper than what's needed. So if I go into my toolpath and I go to my heights tab, my bottom height is currently selected to the contours and the edges I picked. Well, I would like to go to model bottom. And I'm going to go ahead and hit OK. And what you're going to notice is even though I said I'm not going to model bottom, the problem is I'm still not going all the way down past the bottom of my part. And the reason for that is because we're using a roughing strategy that has actually got stock to leave in the Z axis. So again, I want to adjust my blue line. I go to my passes tab. I have radial stock to leave and axial stock to leave. Now, what we're looking for is axial, right? We have 20 thou. So if I go back to my heights tab, I need to subtract at least 0.02, or in this case, I could actually go a little further, which I'm going to take it past roughly 50 and hit OK. And now you can see we are machining way down past the bottom contour of what we have. One neat thing about this toolpath is we could actually do the inside area as the same time as the outside. So again, I just did one area of my part. So I just did the outside. I could go back to that same toolpath if I wanted to do the same thing inside, pick my inside edge, and then again, hit OK. And as you can see now, I'm now boring out and milling out the inside of my part. Switching from this to a 2D pocket strategy, the difference is mainly going to be that the pocket strategy is utilizing the actual width of the tool, not the flute length. So again, as I'm picking my two edges, I'm telling it I want to go to model bottom minus 50. And then lastly, in my passes tab, if I go ahead and look at my maximum step over, again, I'm using a 1/2 inch end mill. So I may actually be able to go like a 450 step over. And then I want to do this in depths. So let's say we're going to do 100 thou step downs. What you're going to notice now is this is very, very kind of straight line or single pass, but we're going to make a lot of passes stepping down in a small increment. Now, a adaptive clearing is going to be kind of a deep pass with small step over, if that makes sense. Again, adaptive, the best way to think about it is using the flutes. Pocket clearing tends to be using the tip of the tool or the full width of the tip. Again, this is where I tell everybody, it doesn't matter which strategy you choose. Based on your machine horsepower, based on what works best on what you're doing, that is going to determine more of what's going on. In most cases, using a traditional end mill, I always go adaptive clearing. Now, that's just me. If I'm going to use a pocket or like a insert mill, I tend to go pocket clearing. So now let's finish up the part, right? So we've roughed it out. We roughed it out plenty deep. Let's go ahead and make a finishing path around the outside to give this some nice clean faces. So again, I'm going to go back to my 2D menu, and I'm going to move down to this next section, which tends to be our finishing, and I'm going to grab the 2D contour. So from here, again, I could just hit OK, but we should be in the mindset in 2D, I have to give it geometry. So I'm going to go ahead and give it the geometry that we've been giving it so far. So I'm going to pick my lower edges around my part. And then from there, again, is we're going to set our heights. So we're going to go all the way to our model bottom. And this time, I'm only going to go past the model bottom by about 20. And I'm going to hit OK. So as you can see here, and this is where it's going to seem a little tricky, but we did rough past 30 technically, because we had 50, and then we took 20 away because the stock leaves. So there is about a 10th step here. Not a big deal. This keeps my tool away. I don't have to worry about anything, but we are still cleaning up a path all the way around the bottom of our part. So we're doing our inside and we're doing our outside. Now, depending on your machine and what you're doing, you may want to adjust tool wear at the controller. I could do so here in the passes tab. Again, those blue lines, we could change it from in computer to in control, or my favorite, just turning on wear, which is going to give us a D value when we post out our part. So let's go ahead and do our spot drilling and our drilling of our holes. So let's go up to our drilling tab, and we're going to go ahead and select our spot drill. And in this case, I'm just using a 1/2 inch by 90, and I'm using a spot drill. By all means, inside of Fusion 360, when you filter, I don't prefer to use a center drill unless I'm using a tailstock. I'm actually using a spot drill. And the reason for the spot drill over the other is the fact that I can actually have both a milling speed and feed and a drilling speed and feed, because I'm going to use this as a chamfer tool as well. But to start with, we're going to go ahead and pick our aluminum drilling. And then again, our geometry, we're using a 2D toolpath. We have to tell the software where we want to go. And because this actual chamfer is actually there, I can pick the chamfer face, and then I can tell it to pick the same size diameter, going through and selecting all those faces automatically for me. So again, what this is doing is actually setting my chamfer depth perfectly with that 90° to that edge all in one shot. So given that we've now done those holes, instead of drilling out my holes now with a 3/8 drill, I'm going to go in and I'm actually going to chamfer the outside of my part. And this is where a lot of people get confused, because there is a chamfer path, which works phenomenally. But this chamfer path is more kind of like our newer path, deburr, where it's looking for a hard square edge and you're breaking that edge. Now, I have a modeled chamfer, meaning the engineer actually put a chamfer on this part. So what I'm actually going to do is I'm going to use 2D contour. And 2D contour is going to, again, allow me to pick some edges. And I'm going to pick that lower edge around the outside of this part. And then I'm going to go to my passes tab, where you're going to notice you have the chamfer checkbox. Well, my chamfer width is going to be 0. And you'll see why here in a second. But I do want the tip of my tool to go past maybe 30. And in this case, the reason why I'm getting an error is because I am not using the aluminum finishing speeds and feeds. So as you can see here with this tool, we are now 30 thou below that edge. And as you can see with my model updating here as we get into position, we are using the edge of the chamfer tool based on that defining. So again, when you have a model chamfer, the best thing you can do is actually use a 2D contour around the outside of your part. And at this point, we've actually finished everything up on this first half. So before I go ahead and flip this over, I do want to tell you all that at any time you are welcome to use jitcadcam's support system. The link is in the bio. You guys can also find this model down below with a link to download and practice this yourself. Not to mention the fact that you do have the ability at any time to reach out to us directly so that we could do custom one-on-one trainings with you and your company to get you up and running even faster with Fusion 360. In order to flip our part over, what we're going to actually have to do is we're going to have to create a brand new setup. So what I'm going to do is I'm going to go ahead and go up to my setup area, and I'm going to say new setup. Now, again, we're going to walk through this all again. So I'm not selecting the machine in this case. I'm doing milling. I need to set my Z-axis to the backside of my part. And in this time, I'm actually going to put my X-axis the opposite way. And the reason for that is so I can use the fixed back jaw to square this part up and hold it. So I can click the tip of the arrow for X, and as you notice, it's going to automatically flip which direction. I also have the checkbox over here on the right to set this. Again, I'm going to go ahead and base this all off of a actual location. So this time, though, because I have this nice big old bore here in the center, I am going to use a selected point, and I'm going to base that point off of center of my bore. So now what I'm going to have to do is I'm going to have to deck this hat off and then make an adjustment to the center of the bore. However, this is a hard reference point from op1 to op2. On the stock side of things, you're going to see from preceding setups already coming through, and I'm going to go ahead and add in continuous rest machining. And what that's going to do for me is bring through my stock body, as you can see here, with my hat from my first operations. So first thing we're going to do is we're going to deck this thing off. So let's go ahead and do a facing toolpath. I'm going to go back to my 2-inch face mill. And then we're going to go ahead and actually add some depth of cuts. So let's go ahead and go over to our passes tab. We're going to turn on multiple depths, and I'm just going to do a 50 thou step down based on that. So as you can see, we're now decking off the backside of our part. Our stock model is updating accordingly, and we have that second operation down. So here we can go in and we can, again, rinse and repeat. Do I want to spot drill the backsides to get those chamfers on there, or do I want to actually go around my part and chamfer them? Either or doesn't matter, but we're just going to do the same thing over and over. So I'm going to go to that 2D contour. I'm going to swap out to my 90-degree half-inch spot drill. We're going to use aluminum finishing. And then I'm going to pick, again, that lower edge that I would like to chamfer around the outside of my part. And we're going to set that offset to, 30 or 50, depending on what you're doing. So let's select our spot drilling. So we're going to go ahead and go to our drill toolpath. We got our 90-degree spot drill. Again, being cautious of our drilling speeds and feeds. We're going to pick our geometry to spot drill. And with that being said, we're able to hit OK. So I didn't drill my part from the front side because I wanted to use those spot drills to actually go in and place them and then do my drilling from the backside so that I have it pre-chamfered. So the last thing I would have to do on this backside is do, again, another drilling operation. We're going to pick a 3H drill. And we're going to go ahead and do the old speed wheel move down to 0.375 using our aluminum. And again, we're going to pick our face. This is where we could go through and pick the same size diameter as you guys remember. And then lastly, I would like to actually go all the way through the bottom of my part. So I'm going to say drill tip through bottom, and then I could give it, again, an additional little bump to get it down through the bottom of my part. So as you can see here, we're now going in doing our drilling after our spot drilling. We've done both sides of our part, and we can go ahead and start to post G-code. So it's up to everybody how you feel that you're going to actually do this at the end of the day. If I was going to run just 4 or 5, I may run op1 by itself. I may run both of them. So you could actually use the control key to pick multiple setups. If I wanted to walk this through slowly, again, as I can pick several toolpaths in one shot, but I'm going to go up to the top and we're going to go ahead and simulate this just to make sure everything is okay. So let me get flipped back over to the other side. Personally, I am going to go ahead and make my stock turned on. I like to look at it as a comparison. So if I see any collisions or any material left, I'll see that in real time. And then from there, we have the ability to go ahead and simulate this path. So I'm going to go and hit the play button. And we're going to watch this guy walk through. Again, let me just get repositioned here a little bit better for all of you. And as you're seeing, we're going around, we're roughing the outside of this part. Roughing out our inside area. And if you remember correctly, we actually went ahead and set 2 roughing strategies to the backside of this part. So that's why you're seeing a second go around of roughing. Now, I may delete one of those based off which one I like better. Again, I'm more of an adaptive clearing guy on a part like this. But if I was doing large molds and large cavities, I would actually be going through with a pocket clearing. So everything's checking out very, very well. We don't have any collisions. We're not hitting the actual shank of any of my end mills. It would have told me that. There's my nice cleanup. There's my spot drilling. And then lastly, my chamfer around the outside of the part. So again, everything's checking good on this toolpath. We've simulated. Now we can post-process. So based on your machine, you are going to have a post-processor. So what I'm going to do is I'm going to go ahead and select a post-processor from the library. And for the sake of this demonstration, I'm actually going to just put this right onto a Haas machine. So we can put this onto a Haas next generation control. And that's going to cover basically any of your vertical mills. Now, if you have the pre-NGC controller, you would have to use the pre-NGC post. This is the inspect surface post. You may not need this one, but there is another one called the pre-NGC. Let's go ahead and choose a location to put this, and I'm going to save this into my cloud. And now, as you can see, all my information for my setup is pulling through. The folder that I want to put this in, I'm going to put it right onto my desktop. You're probably going to use a thumb drive or a network drive for this. And then I do have the ability to toggle things based off what's going on. Again, if you have an A-axis, things of that nature, you can change. Again, getting down here into these other settings. Again, if you don't know what this is, by all means, guys, you could reach out to me directly using the link below. Put in a support ticket with us. I'm happy to spend some time and get this set up so that it's tailored best to what you're doing. But again, for the sake of just getting G-code out of the software, I pick my post processor. I'm going to go ahead and hit post. As you're going to see, it says post successful. We're going to view our NC code. And just like that, we have our G-code to go run the machine. Now, as you're seeing, because that offset 1 that I put in, we have G54. Now, if I wanted to go back, and we've kind of talked about this, where we're going to actually use a second offset for our second operation. So I'm just going to grab the 2 facing cycles for the sake of this and post them. Again, using that post processor. And with that post processor, I have the ability to actually spit out both the G54 and the G55 cycle for my machine. So again, super helpful to be able to, take something from 1 or 2 parts maybe to a full production kind of scenario, or to make your actual jaws on your machine flippable, ambidextrous. Thank you all for, again, watching my video. I appreciate it a ton. And I just want you guys to know, before you go off and start the rest of your day, or, possibly go home, let's go ahead and give this video a like so we can get it spread out to more people due to the algorithm. As well, leave a comment with any information you have or anything you would like to see in upcoming shows. And as always, don't forget to click subscribe so you get notifications anytime and every time that we are releasing a new video. Thanks again. Have a great rest of your day.